Hello, today we're going to have a game of bingo. What I want you to do is to shout bingo when you think the definition or the meaning of one of these words comes up. And then what we're going to do is together we're going to fill in the table that you should have written in the slide before. The words are current, charge, voltage, resistance, ammeter, meter, ohm meter, multimeter, conductor, insulator, potential difference, circuit, series circuit, parallel circuit, continuity tester, and the effects of a current. So let me show you what I mean. Electric charge is produced from the outer parts of atoms called electrons. When these small charges or electrons move around a circuit, we call this a current, electric current or electricity. Bingo. Why bingo? Because it says here that a current is electric charges moving round a circuit. So we could get our table here. I've got my 16 words down here. Whoops, I've given you the next one, and I could copy this one and I could move it. So I could move my box and place it where it says electrons passing through a circuit. Let's go on to the next one. When an electric charge passes through a conductor, it produces several useful effects: heat, light, magnetism, and chemical effects. Bingo! Did you get that one? And it is P, the effects of a current. The effects of a current are heat, light, magnetism, and chemical effects. So I think that's already in my table. So effects of a current, heat, light, magnetism, and chemical effects. Let's go back to paragraph 2. You will only get an electric current if there is a complete path for it to follow. This is known as a circuit. Bingo! Did you get that one? So that's a circuit. And what's the definition of a circuit? Well, a circuit, if I can copy it, is, let's find it, a complete path for the current to follow. Did you beat me? We'll get there. That's 3 words done. Complete path for it to follow is a circuit. For example, a light bulb will only light if there is a complete path from the power supply through the bulb and back to the power supply. We use the symbol I to represent current, so we don't have to write out the whole word. You probably think that we'd use C for current. I was used as people used to refer to current as intensity. So that starts with I. The unit of current is the ampere or amp, and current is measured using an ammeter. Bingo! Ammeter is a device for measuring current. So let's fix that in. So here, ammeter, an ammeter is a device for measuring current. Ammeter, a meter to measure current. Current is measured using an ammeter. Ammeters are connected in series. The symbol for an ammeter is A in a circle. Paragraph 3. Electric charge cannot flow through all materials. Materials that charges can flow through easily, such as copper, are called conductors. Bingo! What's that? That's a conductor, and a conductor is a material that electrons can flow through easily. So make sure you get the right one. Material that electricity or electrons, really, we should change that to, can flow through easily. Okay, let's keep going. Materials that charges cannot flow through, for example, rubber, are called insulators. Bingo! Insulators are materials that electrons can't pass through. Really should make that electrons, and you should do the same on your sheet. We're doing well. Notice materials that are good conductors of heat are also good conductors of electricity. Materials are bad conductors of heat are also bad conductors of electricity, or we can also call those good insulators. So if you know that heat travels through a material, then electrons will also travel through that material. Paragraph 4. The number of free electrons in a substance determines how well it will conduct. Metals such as copper, aluminium, silver and gold are good conductors because they have at least one free electron per atom. Some materials Some metals, such as lead and tin, are poorer conductors than other metals because they have less than one free electron per atom. Substances with no free electrons, such as glass and rubber, do not normally conduct, and they're called insulators. Paragraph 5. Resistance is a measure of how difficult it is for these charges to move through an object. Bingo? Good. So we've got resistance, and resistance is how easy or hard it is. There we go. Is a measure of how difficult it is for current to move through an object. Hope you're keeping up. Resistance changes electrical energy into heat. Not all conductors are equally good at letting charge through. Some resist the current more than others. We say these materials have a high resistance. Resistance is represented by the symbol R and is measured in ohms, symbol omega. Resistance is measured with an ohm meter and has the symbol omega in a circle. Did you get the bingo? Bingo. An ohm meter measures resistance. So if I look for my ohm meter here, my ohm meter is a meter to measure resistance. And you should have noticed that that's why we've called our block ohm comforts. Get it? Ohm comfort. Now on to paragraph 6. The electrical push that allows charge to flow is called voltage. Bingo. So voltage near the bottom. Voltage is the electrical push. Let's see. Look here. So voltage is the electrical push. It is also a measure of the energy given to each charge as it passes through the supply. Potential difference, PD, is often called voltage. PD is the difference in the amount of energy that charges have between 2 points in a circuit. Bingo. So potential difference should be here. There's not many left. Here we go. Difference between the amount of energy that charges have between 2 points in a circuit. Voltage is measured in volts. Voltage is measured using a voltmeter. So there's our next one. A voltmeter is a meter to measure voltage. How many have we got left? We should have just one left at the end. So we're nearly finished. I hope you've nearly finished your table too. Voltmeters are connected in parallel, we'll explain that later, and have the symbol V in a circle. A circuit that can be built to test whether something was a conductor or an insulator is called a continuity tester. Bingo! Now you made one of those, a continuity tester, when you made your own circuits, if you did that, or when you tested the materials such as the scissors, that was a continuity tester. So it is a circuit to test whether something is a conductor or an insulator. Nearly finished. Rather than using a separate meter to measure current, voltage and resistance, one meter can be used on different settings. This meter is called a multimeter. Bingo! Get it? So a multimeter is a meter to measure different quantities, and we've seen that in the last lesson. Soon we're going to find out that there are two types of circuit that we can build. A series circuit is one where there's only one path for the current to take. Bingo! So a series circuit is a circuit with only one path for the current to follow. Remember that in a series circuit, there's only one path for the current to take. Charges flow through all the components. In a parallel circuit, there is more than one path for the current to take. Bingo! So a parallel circuit, a circuit with more than one path for the current. And if I go back to the picture, this one's a series circuit, so there's only one path for the current. And this one has got two little blobs. We said that those are connecting wires, and that makes that a parallel circuit, because at this point you could either go through this bulb, or an electron could go through this bulb. Now that's the end of the paragraph. So if we go to our words, we should just have one word left. Okay, so we've done an ammeter, we've done a circuit, we've done current, we've done insulator, we've done potential difference, we've done the effects of a current, which just leaves me one word, and that's going to be the charge. So the charge is the quantity of unbalanced positive or negative ions in or on an atom. Your task now is to go away and, using the word wall, you need to learn those 16 terms because they're really important. Thank you for listening, and I hope you've enjoyed the game of bingo. Electrons passing through a circuit. The effects of a current: heat, light, magnetism and chemical effects.